Okay, so what we're working on today, guys, is a one sample t-test. So now we're talking about means. And you remember when we go back to the discussion, when we don't know the population mean and we don't know the population standard deviation, we have to use the t-distribution. So we're going back to that t-distribution. So let's just get a little practice with our alpha level and p-values. So this first one, my alpha is 0.05. Here is my t-test statistic. So this is the number of standard deviations away from the mean. Okay, but we don't call it technically standard deviation, it would be standard error because we're using that sample standard deviation. And my n is 15, so my degrees of freedom would then be 14. So let's look up what the p-value is. Alright, so here's how this works. So I go to 14, and my value is 1.054. So I'm going across. 1.054 falls right in between these two values. So my tail probability is somewhere between 0.05 and 0.10, okay, because it falls right in there. So my p-value is between 0.05 to 0.10. But look, I set alpha at 0.05. So is that enough to reject? No, we'd fail to reject. Okay, let's look at the next one. Now this one, actually let's look at the one over here. So we got negative 1.37. I'm going to use degrees of freedom are 19, and alpha is 0.01. So again, I'm going to 19. 1.37. Notice I don't have negatives. I just got to flip it around because it's symmetric. Right? So if I look at this, I just flip it around with the negatives, I'm good. 1.37, so my p-value is between 0.05 and 0.1. Again, it's right in there. So it's between 0.05 is less than 0.1. But what do I notice? It's less than that. So therefore, I would reject in this case. All right. And in this one, t is 3.14. I would have degrees of freedom are 54. Now, I don't have 54 on my sheet. Okay, so I go down to 50, and it was 3.14. So I go all the way across. 3.14 falls in here. So my tail probability is between 0.0025 and 0.001. Okay, but notice it's two-sided in this case, so I need to multiply these by 2. So it'll be 0.005 and 0.002. But notice both of those are less than 0.01, so we'd reject HO. Real fast, let me show you how to do this on your calculator. A nice easy way, you go Menu, Statistics, Distributions, TCDF, right down there. We always use CDF. All right, we'll use the first one, letter A. So my lower bound is 1.54. My upper bound is something really big. And my degrees of freedom are 14. And this gives me my p-value exactly, 0.07. Is that what we said it would be between 0.05 and 0.1? It sure is. So that's a nice, easy way to do it. Again, you can rewind if you need to do that. Okay, let's go ahead and do a test now. All right. So on the other side, let's take a look at the one with the French fries. Alright, looking at the French fries. And you can read the problem so you see what we have. But what we have is we have a random sample of 30 sets of French fries from McDonald's and their mean weight. So what I did is I plugged these into my list to start off, and then we're going to work from there. So we want to see, are they meeting that target? So our null hypothesis, mu is equal to 171. Our alternative would be that mu is less than 171. They're selling bags of fries that are underweight, where mu is the true mean weight of Mickey D's. All right. Notice I'm talking about means now. I can't say proportion in there. It's a means question. This isn't categorical data. It's quantitative. Okay. So conditions. First, assume it's a random sample of all fries. Fair to do that. And more than 300 possible bags of fries. The 10% rule still there. And n is 30. 30 is a large sample size. So we have that central limit there. 30 is bigger than 25, not that way. So we actually are good to go with the central limit theorem. If it was smaller than 25, I'd need to look at the graph and see if I had normality out of there. Remember our rules for the t-distribution. All right, this is a one sample t-test for means. Oh, and I need to set my alpha level as right there at 0.05. And if you look on the sheet to the left here, I'm following those directions. It's a great way to do these. And I'll practice those more in class with you. So you can see I got my pH, my A and my N, my test statistic, and my p-value. So now I need to get that. Okay, so here's my formula. So let's plug it in. So we got x bar was 139.067. minus 171, all divided by s, 26.6 over the square root of 30. My degrees of freedom in this case are 29, so I go through and do this, and now I'm just going to jump to the calculator and run the test. I'm going to go Menu, Statistics, Stat Test. I'm doing a t-test. Alright, I've got the data, so we're good. I'm going to tell it my null hypothesis is 171. My list is fries, and my alternative is that it is actually less than. I'm just going to follow the alternative. Hit enter, and so let's see what we have here. So there's my t-test statistic, and there's my p-value, and my degrees of freedom. You can see it right there. And so we got test statistic is negative 6.5257. My p-value is 0.000001. And what do I know? That's my O, so now I need to make a decision. 0.000001 is less than 0.05, so what are we going to do here? We're going to reject that null hypothesis. Okay? And now we're going to state the conclusion in context. We have statistically significant evidence to say the mean weight of fries is less than 171 grams. And what I might do here is go make a confidence interval real fast. So Menu, Stat, confidence intervals. We're going to do a t-interval. Again, data, list, fries, 95. And my interval is actually between, where'd it go? Menu, Stat, confidence intervals, t-interval, data, fries. There it is, 129 to 149. We're confident the mean weight lies in the interval 129 to 149 grams. And there we go. That's everything you need to do for this problem. Phantoms, follow those steps and just work off of that. All right, thanks.